Hey guys. Uh, yeah. Today we will learn about kind of a more deeply about the role of reactive power in a power system. So previous lecture we learned about the reactive power, right? But we still didn't understand what is that exactly, right? So let's see here. So as you guys can see here is a triangle, right? And this part we want to know reactive power, right? So it's a totally different, as I said, reactive power and active power. Active power, I said, was actual usage, man, actually use and actually works. But reactive power is, give you money or anything, yeah, and then return it back like that, right? So if we see the graph here, the yellow part, so the average is zero, no loss, you know what I mean? So, to understand the reactive power, you guys should try to do searching, like a website or, you know what I mean, the book. And you guys may see many of this picture about the beer, you know what I mean? So generally they say like because we cannot understand the reactive power, right? And the active power, directly. So we using this picture, and the bubble part is a reactive power and real power is active power. But actually, if we say oh, reactive power is just a bubble, then real power is just, beer itself. But it's the kind of different, but actually just beer. In power system, if we explain like this, how we understand, you know what I mean? So let's try to understand the kind of deeply and logically, you know what I mean? So first of all, reactive power in the picture, this beer cup, the bubbles, there's something purpose, for the bubbles. It actually adds some taste for, kind of a good taste for the beer. So which means it actually something do, you know what I mean? As it exists in the beer. Reactive power is also same meaning. It actually something do, you know what I mean? So in electrical, power system, we say this is a medium for the transmission for the active power. You know what I mean? So it's kind of a bridge. You know what I mean? Here's a active power, and we need to make it active power here, like a power from power generation to the motor or our load. You know what I mean? So we need to we make it power generate power here to move to here, like actual working for motor or something, right? So between them, there's like a load. I mean, I would say bridge. You know what I mean? The medium for the transmission for active power is a reactive power. Now you can understand what is it, like a kind of a bridge for the moving to active power to some point to another another point with active power. Let's see more. So what I want to say is here. So we already, I mean, it's also related to dynamics a little bit. Or I will try to explain. Um, let's see here. First of all, what I was to say was here, generator, right? And then we need to use here, motor also. Oh no, motor is, it need actually needed it need first of all generator part, it need to make up active power, right? And then motors actually also is working, so active power needing, right? Active power. So reactive power is, as I said, reactive power is needed like a medium for this, from this active power to move to the active power, like a bridge, you know what I mean? So I'll give you a question. If there is no reactive power, what happened to here? Do you think that this motor is working? Of course not. Really, you know, you believe me, it doesn't work if you give like only active power to active power here. So, where is it? Yeah, yeah, that's what I explained. And here, you can see here active, power and reactive power. Let's see. Okay, here's I will try. Here's a horse. Sorry about it. There's a horse, and then here's a load. But like so look at that. First of all, I wanna say is the work is so I will explain a little bit about dynamics. Okay, this dot and the L force and L is L vector is I will say destination. You know what I mean? Like an angle. I explained about that is indicated efficiency, right? So, like for example, horse wanna go to this way, right? So L vector is here, this way, right? But since the horse is here, right? For some reason it cannot be here. I will explain why is it here, right? So for example, here's a river. So horse has to be here, right? Because it cannot, carry this road or on the, on a boat to some road. It cannot uh, move. You know what I mean? Our stuff. So it gotta be it here. So actually, force is, I will say is this L vectors here, right? But the force is also here, right? But since this is, force is here, so which means it actually between them there is a distance, right? So this part is, I would say, reactive, and this is active here, and this is actual apparent power, right? So look at that here. So we could say if we change it to this dot to FL, sorry, FL cosine theta. So cosine is, look at that, from here to here to here, right? So cosine 1, is 100%. Cosine 0 is 100%, right? Cosine 0 is here, 100. We will say 1. So, like for example, if the horse is, here, and the load, it's not river, okay, here. The boat is here, and the load, you know what I mean, our stuff. This is, we say, cosine theta is 0, it's 100%. My force and my L vector, like angle, you know what I mean. So it's 0 means, it makes 100% efficiency, you know what I mean. But look at that here, just reactive power. Here, the horse wanna go to the here, right, L vector. But because of the force, reactive power also needed, it needed, because by the way, because of the angle differences, it needed also this power. Actual power is it needed this, but also it needed this power, we say. So between this part, there's 90 degrees, right? So which means cosine 9 is 0. So we say this is reactive power. Actually 0, what I mean. But which means just the angle differences. But what I wanted to say is it needed, to move this stop. You know what I mean? Yeah, so let's see here more. So nowadays, I'm saying is nowadays we use RLC load. You know, our circuit is there's no pure L, no pure R. You know what I mean? If it's a horse here, I will say this on the load here. I will say this is a pure load. You know what I mean? But since we use RLC, lots of different kind of load, so that's why we has to be use reactive power. So I said apparent power, actually this part needed, but yeah, this is actual usage, right? But what I mean is the real power and we say the destination, you know what I mean, the angle is there's differences because of our system. So that's why it's reactive power is needed. What I mean is, hope so you guys understand, you know what I mean. So if you guys are confused, just let me know. Like what I said was many times I'm continuously I'm saying because it needed some time to understand this part. But okay, I guess this is a good explanation. Okay, here you and you need to climb up, and here's like you need to. There's a big box. This is a ladder, right? And you need to put in here something. Okay, something water. You need to put in here, in the box. So if you holding this water to the here, climb up and water here, pick up is actually working, right? Actually, you do working. After finishing, you will get the money like $10,000, like if you finish it in one day, like for example. But it actual working is you grab this and then put in here and then feed up. It makes the actual working. But if you didn't bring this, what happened? You working, right? But actually you didn't do anything. You yourself worked. But if you just climb up and then go down, doesn't work, right? Actually doesn't work. But this part also needed, right? So that's why I'm saying this is part is reactive power to like a medium, like for the transmission, for the active power, right? Yeah. Yes. Yeah. So as I said, we will learn later about power, I mean transformer and motor and the generation part. But don't don't get shocked. This is just transformer. So this is primary part, and later we will learn. Okay, don't worry. Secondary part. So I will say this primary part, I will say generator for us, because we get it just a power source from here, and the transformer's main purpose is I mean just make it, I mean, from primary power to the secondary power, just up and down, you know what I mean, powers up and down. It depends on. So I mean, for main purposes, power loss, it needed actually power, transformer. But what I want to say is today is primary is from power P1 to move to secondary, part to load here. So its efficiency is almost 99%, almost 100%. What I mean is, but how to move the active power to primary part and the secondary part? It needed this pi m, magnetic field flux. It needed, because it works like a kind of bridge. You know what I mean? If there isn't this magnetic flux, you know what I mean? It cannot move to the power to the power. For example, also look at that. This is a motor, right? So actually, electrical energy, it get it from the source, and then it making mechanical energy is a move. motor's main just basic definition, right? So if there is no flux in motors, it cannot work. You know what I mean? Actually, this is power to the real power, right? Rotating is also real power, right? Real actual working, right? But if there's no reactive power, it cannot, work. That is this is the result. And then, so look at that. I explained here. Okay. So this is core, for example. So which current, active current, or I explained this before, right? Active current or reactive current, which one is make it this magnetic flux? What do you think, guys? Look at that. So first of all, we need to know. Here's the V0. I said I try to drawing the simple picture, but since we use a voltage system, so reference is voltage, and our general load power systems is like this, a little bit lagging. So I minus theta. But here, this part is I cosine theta. This part is I sine theta, right? So just try to, just you guys don't need to about this. Just memorize the result. Active power is V I cosine theta. The reactive power is V I sine theta. This is the result, right? So reactive power is here, right? So we need to move on here. Okay, guys. So what do you think you guys need to make a magnetic field? Coil is, I said, coil and capacitor, I said this is exists in the imaginary number, right? So which means here, reactive power. So actually the reactive part of current, it makes it magnetic field. That's what I'm saying. You need it, to move the power from here to the load. That's why we needed reactive power, right? So later we will learn about the generator part. So look at that. Generator is, this dot, you can see the black dot. This is, I will say, for example, if there's a, like a stick, prime mover, like let's think from this dot to connect it this bar, right? So generator is, using some hydraulic or nuclear or, wind, using some kind of, power, and then it make it, rotate it, right? Something power. And then it generate the power, right? But what I meant is, so prime mover, it needed to move, right? But it's a rotor is it needed rotated, right? So prime movers it needed rotated, which means it make it the rotors rotate, right? So it needed some power. So which means active power is related this, power, how fast it is. It's a related frequency. Later we will learn. No, we will learn about this. Okay, just try to relate this word. And but this is just a core, right? If we just turn the core, with rotors, and then how we could make up, power, you know what I mean, voltage. So it needed, that's why it needed here excitation voltage. It needed, you know what I mean. So we say this is the excitation current here. It's connected to the rotor part. So it's controls the reactive power, this excitation voltage. You know what I mean? So yeah, that's it. I wanted to say was so just try to understand. You can see here rotor, and here we say this part is gray part is stator, but between them there's air gap, which means actually there's gap between them. Like if it's rotor here and stator is here like that, so it between them there's no actual connection. But how it move power from the rotor to the stator, reactive power is like working as a bridge, you know what I mean, to move. So reactive power is controlled by this external excitation voltage. Later learn it, okay? Don't worry. And then the actual active power is, I said, the rotors, it needed rotator, right? Rotating. So it needed from the outside of power. So I would say this is, it depends on the hydraulic or something. Yeah. So we say is this is a frequency related, how fast it is. Yeah. Today lecture is done, guys.